Now that we've taken our excursion into fully explaining marginal cost at the firm level, we're going to bring back in total cost. Now, remember, total cost equals total variable cost plus total fixed cost. And we were going to connect that with the concept of marginal cost. We need to, because a rational agent makes decisions on the margin. A firm is a rational agent, and therefore whatever output decision they make is going to involve this concept of marginal cost. Now, so how can we connect the two in a model, in a graphical model? Well, one thing really sticks out is that the scale of total cost and marginal cost are completely different. Imagine Sony, okay? Say you're looking at Sony's production of 48-inch flat screen TVs. Well, if they produce 100,000 TVs, you're looking at millions of dollars in total cost potentially. If you assume each TV sells for $400 and the cost of production is $300, then you're looking at what is that? 300 times 100,000 TVs would be what, $30 million in total cost. But marginal cost is the cost of producing the next TV, which would be somewhere around the $300 range. So we have to rescale total cost in order to bring it in line with this concept of marginal cost. Again, this would, if Sony were making 100,000 flat screen TVs, total cost would be in millions of dollars, but marginal cost, the cost of producing the next TV, which would be in hundreds of dollars. So we have to rescale total cost. And the way we do it is simply dividing through the function by Q, which is a perfectly legitimate algebraic operation, okay? What this gives us is average total cost will equal average variable cost plus average fixed cost, okay? And average total cost specifically is total cost divided by Q. Average variable cost is total variable cost divided by Q, and average fixed cost equals total fixed cost divided by Q. In other words, these are simply average per unit costs. Okay, and so the marginal cost, the cost of producing the next TV, may be $300. Well, what's the average cost of producing all TVs? Well, it's probably somewhere, say, between $250 and $350. So now we're down into the hundreds of units, okay? So now the question becomes, what does this look like if we graph it, okay? That's what we're going to explore now. Now, what I'm going to do, and you've probably seen me do this in a few videos and wondered what I'm doing. I'm just putting dollars on the vertical axis, okay? Not, the dollars includes prices, includes costs, includes everything. So instead of having a P here, we're at the firm level. We're now considering cost specifically. So I'm just going to put dollars on the vertical axis. So remember, our objective is to find out what average total cost looks like, and average total cost equals average variable cost plus average fixed cost. Okay, now let's start with average fixed cost. So what does average fixed cost look like? Well, mathematically, as we just stated, average fixed cost equals total fixed cost divided by Q. Total fixed cost is not a function of Q, okay? So total fixed cost is just a constant, okay? So you have a constant divided by a variable. What does that look like? Well, we all know the famous equation that we learned back in algebra, y equals 1 over x. This is exactly the same function, believe it or not. If I have average fixed cost on my vertical axis and q on my horizontal axis, well, average fixed cost is simply y. Q is simply x. So as I increase x to infinity, okay, keeping the numerator constant. If I increase x to infinity, what happens to y? Well, it goes to 0. If I send x to 0, okay, as I move x infinitely close to 0, what happens to y? Well, you have something infinitely small underneath something that's constant. Y is going to go to infinity. So, same thing applies here. As q goes to infinity, average fixed costs go to 0. As q goes to 0, average fixed costs go to infinity. Okay, so that is our average fixed cost function. Okay, it looks just like that. It looks just like y equals 1 over x. Take out your Texas Instruments 85 calculator and graph y equals 1 over x, and you'll get a function that looks like that. Okay, so now we've graphed average fixed costs. Now, what does average variable cost look like? Well, at this point, we can directly connect average variable cost with marginal cost, and we can do it this way. Think about like this. Okay, so you've been to college for 2.5 years now, so for 5 semesters, and you have a cumulative, okay, cumulative GPA equal to a 3.5. Okay, if on your 6th semester, which is your marginal semester, okay, your GPA in that 6th semester is a 3.0, what's going to happen to your cumulative? It's going to fall. Okay, now if your marginal semester in your 6th semester, your GPA was a 4.0, what's going to happen to your cumulative average? It's going to go up. Okay, in other words, when the marginal GPA, the GPA of the next semester, is below your cumulative average, okay, it's going to pull the average down. If it's above the cumulative average, it's going to pull the average up. The same concept applies to average variable cost and marginal cost. Remember, they're both variable costs. Okay, marginal cost and average variable cost are both variable costs. So they're both going to, how do you know that? Because, well, first, marginal cost, the function changes over Q. In fact, the function looks like this, okay, as we discussed earlier. This tells me it's a variable cost. It changes over Q. Now, what does average variable cost then look like? Well, when marginal cost is below average variable cost, it's pulling the average down, okay? And when marginal cost is above average variable cost, it's pulling the average up. And that is our average variable cost function, okay? So now we have these two functions. We have average variable cost and we have average fixed cost, which looks like this. And remember now, average fixed cost is also varying over Q because average fixed cost is itself a function of Q, even though total fixed cost isn't. So yes, this is changing over Q, which means it is variable, and that's because now average fixed cost is a function of Q, even though total fixed cost isn't. Okay, so that's just a little side note for you to remember. Now the question is, okay, what is the best way to embed this graph onto this graph? And the reason is, again, is because we've got average total cost. That's our ultimate objective. We want to model average total cost, and that equals average variable cost plus average fixed cost. Well, if we put this just on top of that graph, it's going to be somewhat confusing. It's because if I choose a Q, say that Q prime there, at that Q, my average variable cost will be that distance there. Okay. Now at that same Q, okay, at that Q prime, my average variable cost will be that distance there. Okay, now you can already see that, you know, if I add those two distances at that Q, then I get my average total cost, okay, to produce those Q. And that's fine enough, but you know, look, this is set up as a summation function, and that's really the easiest way graphically to combine these two, and that's what we're going to do. What we're going to do is take advantage of the fact that this function can be rewritten, and this function can be written as average fixed cost equals average total cost minus average variable cost. In other words, I just subtract average variable cost from each side and I get this function. It's exactly the same function. But what does this mean? This means the distance between an average total cost function and average variable cost function is exactly average fixed cost. What does that look like? That looks like this, okay? Again, let me rewrite that. Average fixed cost equals average total cost minus average variable cost. Okay, we've got our marginal cost function. We've got our average variable cost function. We need an average total cost function. Then the difference between the two functions is average fixed cost. Well, what does the average total cost function look like? Well, average fixed cost, we know that dynamic. We know that at low Q, average fixed cost is very large, and at high Q, average fixed cost is much smaller, and that an average fixed cost goes to zero as Q goes to infinity. In other words, the average total cost function will have a very similar dynamic to average variable cost. Okay, so that's average total cost. But the distance between those two functions will start out large at low levels of Q, and the distance between the two will go to zero as Q goes to infinity. That is our average total cost. Okay, now you can see why we, you know, made this little algebraic manipulation, because now if I choose a Q prime, for instance, at that Q prime, average variable cost can be measured as that distance there. What is average fixed cost? It's the distance between the two curves at that Q. Okay. Now, to get my totals back, okay, what do? Well, I multiply through this function by Q. Okay. So remember, total cost equals total fixed cost plus total variable cost. What does total fixed cost equal and total cost equal? Simply ATC times Q is total cost. AFC times Q is total fixed cost plus AVC times Q. All right. In other words, if I want to get my total cost out of Q prime units, I want to figure out how much does Q prime units cost in total. Remember, these distances here are just averages. Then I would simply multiply through by Q. Okay, so this area here would be total fixed cost. That's simply my average fixed cost times Q. Okay, and I do the same thing to back out my total variable cost. My total variable cost is simply average variable cost times Q. So it is this box here, and that is my total variable cost. I add those two boxes together and I've got my total cost back. Okay, so total cost is simply this distance here at that Q, which is average total cost, and then multiply that by Q, and that's the sum of those two boxes. All that equals total cost. So now we have a nice looking model of firm level costs, and now we can start to think about profit maximization.